I'm here with Payam Tabrizian, and he is a student working on your Ph.D.
Yeah.
at NC State.
Yeah.
And he and his colleagues, Anna and Vaclav, are going to show really kind of an interesting capability to physically create, modify, and then digitize 3D surfaces. I know a lot of you have seen 3D printers, and we've seen different methods, like at the ESRI conferences, of creating a 3D surface and then overlaying data. But this is especially interesting because you can go back and forth and make modifications, and they're taking advantage of very low-cost gaming hardware that is in effect a 3D scanner that provides the sensor that they need. So with that, I'm going to turn the mic over to Ryan and let him explain to you what they're doing.
So, thank you so much for your introduction. So what you can see here, what we call a tangible landscape. It's a system of literally holding GIS in your hand. Although it seems simple, but it's running sophisticated simulations on the back end. So we all know that as the GIS and the software and the simulations behind the GIS improving, it's getting more and more difficult for people, especially people with lower levels of expertise, to interact with these models. So we made it easy. We literally call it, you can hold the GIS in your hand with tangible landscape. The way it works, it's a continuous feedback loop of you manipulating a landscape, and at the same time receiving feedback of all the analysis that you're concerned about. So in this specific example, what I'm showing you is about designing trees. So you can see these are simple pieces of felt. You can draw them, you can draw on a tracing paper, cut them with scissors, or you can use a library of preset shapes that you can see here. Imagine that you want to plant trees, for instance here, these are red maples, and let me put some patches of red maples, and these are eastern pine.
And we can collaborate, so I might not really want to put this here for now.
Yeah.
Just change it.
Which requires points as input, use the interaction with points, and then it would detect the points.
So this Kinect would scan the RGB values. Imagine that you're doing a land use classification, simply like that, and then it classifies the landscape based on different indices that we define. So you can see here, if you come closer, you can see that we have a feedback on number of patches. We have the patch richness. These are very important elements for landscape ecologists to understand the complexity, heterogeneity, and biodiversity of the landscape. So as you add and you manipulate this, not only you would be able to see the science and to work with the science behind the landscape, but you can also see how it looks like. You can feel the landscape, you can literally experience the landscape, be in the landscape and step inside the landscape that you create. So you can see the new patches are generated. So, yeah. So this software that you can see here is called Blender. It's a simply game design, 3D modeling, and animation. So with this, you can interactively work with the 3D model of a landscape, or you can use like mouse, simply to get into the view you want, or you can use a view marker. So this is also a very simple object. This is a piece of wood, and the red denotes where you want to look in the landscape, and this denotes where you want to stay in the landscape. So imagine that you want to have a very good view to the water, at the same time see the red maples. So as you can see, now you can see the maples on the horizon, the same as the river birches that we designed, and on the back that you can see here are the eastern pines. So what happens here is the GRASS GIS calculates the indices about the species, like the landscape metrics. At the same time, Blender, which is, I told you, like an open source software for 3D modeling, computes all these, imports all these computations and converts them to a 3D model. So you can actually have a kind of a more realistic representations of these elements. So this is just one task. It can start from changing and manipulating the landscape, receiving a hydrological feedback, It can be a simple planting design. It can be designing the trails, buildings, and anything. So with this open source software, GRASS GIS and Blender together, you would be able to actually apply your own simulations, your own data, whatever real landscape it is, and try to change it and apply your simulations to interactively modify the landscape and also experience as it looks like in the human and real world views. Talking about real world landscape, this is like a MDF model of where was it, Anna?
It's in Smokies.
Smokies Mountain. So, and that's the landscape there. So we cast these models with CNC router, and these are based on the actual LiDAR representation, digital elevation model specifically. We feed it into CNC machine. It creates this 3D model where we can cast the sand with it. So that's how we start with the real world models to design the landscape from there. And on the other model, you can see an example of showing how you can start from landscape, manipulate, receive the hydrological feedback.
And we also provide an API application programming interface, so you can actually design your own workflows using GRASS GIS and Blender APIs. So if you know a little bit of Python coding, you can actually build your own applications fairly easily. Just by putting together different algorithms, hydrologic algorithms, and so on.
Get the microphone for a minute. Question I had. To me, one fascinating thing about this capability is that you started off with a 3D model in sand, and then I noticed that you were modifying it based on whatever you needed to do. And then you got the feedback from the system to let you know whether you're matching or building a different 3D surface. Is that correct?
Yes. So if you don't actually have the mode you can use for the model, you can build the model from sand yourself. If you have the digital elevation model and contours, you can project the contours, and if you understand the contours, you can build it fairly easily in 10 minutes. And the system also can help you. When you feed it in with the digital elevation model, it will show you how far are you from the desired digital elevation model. With it's color coded, so the red means you have to, for example, remove the sand from that place. You are too high, and blue would mean you have to add more sand. So in this way, you can actually build the model fairly easily. I would say fairly good quality.
Yeah, and I noticed there, of course, that's the example of overlaying the elevation data that you have on that particular model. And you're also showing the streams and lakes and things of that nature.
So another interesting feature that we are excited about is that with ability of working with open source software like Blender and GRASS GIS allows us to have to integrate the interesting developments that are happening recently. For instance, the virtual reality. You can couple Blender with an add-on, virtual reality add-on, to be able to then really literally step into the landscape. So let me have this on. So basically I can experience landscape as it is in a kind of 360 view. And of course we are now running on laptop, so I changed the representations to more abstract representations. With more computation power you would be able to experience this in a much more realistic way. And since you can see here we have two models for landscape design. And also a hydrological analysis. But tangible landscape is definitely not limited to this. As I told you before, with GRASS GIS you can run all kind of geospatial analysis that you're interested for. So for instance, in our center we use applications like disease spread modeling for sudden oak disease spread in California specifically. So how to work with stakeholders to manage different disease control strategies. Or you want to interested in land use change modeling. We feed into a very sophisticated land model developed in our center called Futures, where you can to basically delineate where you want to have development and where you want to preserve the development. So it can simulate the future scenarios. You can work more intuitively with stakeholders and facilitate that decision making. So it's really not a kind of bounded and restricted kind of modeling. It's a very flexible infrastructure that you can implement your own models inside.